Thank you so much for having me, and thank you so much for the kind introduction. Can everyone see my slides? Is it wonderful?
Yes,
so yeah, welcome everyone. Wonderful. So
Susanne, sorry, before
yeah.
you start, can I just check? Are you happy to take questions as you go along, or would you prefer to take them at the end?
Oh, we can do it we can go stop
okay.
me when you have a question. So since I have several displays here, so if we put a question in the chat, I can't see it right now. So if you just like chime in, just like I have a question like verbally, so I don't have a problem with that one, and then I will stop.
Lovely. Oh,
Yeah.
thank you.
So
And yeah, if anybody would prefer to put it in the chat, then Miles, Dean, and I will keep an eye on that for you as well. Yeah.
Wonderful. Thank you so much. Great.
You're welcome.
So welcome everyone from all over the world, so with different time zones involved, and yeah, to Architecture for Flow, Building Foundations for Continuous Change. So yeah, and please, as we said, so please ask a question while I go along. As I consider this as a interactive session, and not me only presenting, but also asking question along the way. So let me see. So Dora's last year's report on AI-assisted software development revealed that AI amplifies your existing flow in your organization, but also exposes brittle processes and friction. So if your flow in your organization is good, then AI makes it better. But if you have a lot of like painful bottlenecks and frictions in your organization, then unfortunately, AI makes the pain worse. So it puts kind of like a magnifier on your organization and magnifies on the one side your strengths, but also your weaknesses in your organization. And if your process or your processes in your organization were already slow and brittle and you had a lot of bottlenecks, here's the bad news. Unfortunately, AI doesn't help to fix your bottlenecks. It's quite the opposite, to be honest. So if you try to improve processes before the bottlenecks, if you accelerate before the bottlenecks, for example, with AI accelerated code generation, then the side effect is that simply more work piles up at your bottleneck. And if you try to accelerate after the bottleneck, that will have no other effect than the team sitting idle. So, and Eli Goldratt, the inventor of the theory of constraints, stated that any improvement made anywhere beside the bottleneck is an illusion. And also, according to the Dora report, if the underlying system does not evolve, I'm sorry, sloths, don't take it personally, but if the underlying system does not evolve, then increased speed turns then into decreased software delivery performance and increased instabilities. So that means that accelerating one part of our system, for example, with AI accelerated code generation, then that will not improve the overall performance if the underlying system does not evolve in parallel. So from a system thinking lens, local optimization of separate parts will not improve the performance of the whole. And as Dr. Russell Eckhoff, one of the pioneers of system thinking, stated that a system is more than the sum of the behavior of its parts. It's a product of their interactions. So the way parts fit together, that determines the performance of a system, not on how they perform then taken separately. And he also claimed long before Gen AI that if the systemic nature of an organization is ignored, the efforts of improving and changing that system are doomed to failure. So that means that we have to focus on flow, not just speed. And that is also stated in the Dora report. So optimizing for the flow of change isn't about going faster and increasing speed, but about removing what slows us down. And in an ideal case, the teams shall fully own the entire end-to-end flow from the first idea to then delivering value to the customers with minimal interruptions and minimal bottlenecks along the way. And that requires also to analyze what is preventing flow. Analyzing blockers to flow can be done from various perspectives. These are just some examples, for example, from the team ownership perspective or team dependency perspective, software architecture and quality or work management perspective. And so if the teams do not fully own the entire end-to-end flow from designing, developing, testing, releasing, and running their parts of the system, then they depend on other teams' activities and tasks to get done in order to get their own work completed. And so that requires to repeatedly hand over work to other teams at a later or earlier stage of flow and to get their own work completed. But handover, on the other side, represent blocking dependencies that requires also a high amount of communication and coordination effort between multiple teams and potentially introduce then wait times and delays affecting our flow of change. And particularly when the teams we depend on, when they are not available when we need them, or when the teams we depend on are so overloaded that they can keep up with the demands, then they become constrained and slow down the overall performance. And then also from a software architecture point of view, tight change coupling impedes also our flow of change that in that way that changes in one part of a system can then have unpredictable side effects on other parts, which also increases then the risk of breaking things and introducing then defects and a lot of rework with unplanned work as well. And from a software quality perspective, accumulated technical debt leads also to fragile code bases that are then hard to maintain long term. And a messy model with blurry and fuzzy boundaries that makes it also difficult to establish clear ownership boundaries. So that potentially leads to a lack of clear ownership, which decreases accountability, which is then can lead also, that's not my job syndrome, that can cause decision delays. And with business logic in this tightly coupled architecture, with business logic mingled together in messy models and no clear modularity boundary, that increases also the mental effort to understand a piece of code and also grasping all the dependencies in this large intertwined system. And so teams often end up owning too many or too large parts of the system. And as a result, their team's cognitive load increases. And if the team's cognitive load is largely increased, then also becomes a delivery bottleneck. And when teams lack priority and focus, they often try to work at multiple task at once, resulting in higher work in progress, jumping between different tasks without completing them, and frequent interruptions and unplanned work are leading to a lot of context switches, which all of them impede also a flow of change and feedback loops. So to who of you does this look familiar, all this pain point that I'm describing? So a lot of like nodding, yes. Yeah, and you are not alone. That is a lot of pain points that a lot of organizations have to deal with. But each of those blockers is bad enough on its own. Now imagine what happens when we add AI accelerated code generation into the system that already had all these problems, right? So then the DORA reports comes back. It states that AI mirrors the structures as defined, so that makes existing architecture problems of this tightly coupled big ball of mud with messy models and fuzzy boundaries even worse. So AI doesn't truly understand domain meaning in the way we do as humans. It's very good at pattern recognitions, and it statistically infers meaning from patterns in its surrounding context. But without clear boundaries in our tightly coupled big ball of mud, AI doesn't know where one domain concept ends and where another domain concept begins. So, and it then potentially, or there exists the risk that within this big ball of mud, AI then fills in the gaps with plausible looking but semantically wrong code, so that it then starts to hallucinate domain meaning and misrepresent then the business itself. And it also picks up whatever meaning, naming and patterns it finds in the code base. So, and if those are inconsistent, then it propagates and amplifies the inconsistency and messy models. And so, and it also has no sense like of architectural intent or architectural cost. So, and without architectural guidance, it mirrors then and generalizes the structure it finds. So in a tangled code base, like in our big ball of mud, with poor modularity and weak encapsulation, it creates potentially even more coupling. So your existing God objects, I guess everyone has stumbled across God objects, which contains, for example, multiple attributes entangling multiple contexts. So I have, for example, an example of an account object, account model with 400 different attributes coming, like entangling so many different contexts. And if you try to change one attribute, you will have ripple effects and side effects you have not anticipated at the beginning. So, and this God objects then become even bigger, and the mess then grows faster, becoming then a large ball of mud, even though. And it's not only that it's about like the technical structure in the code base it finds, but also it also amplifies existing organizational frictions according to the DORA report, such as, for example, the repeated handoffs to other teams, or the high team cognitive load, or the lack of clear ownership. So so AI then generates code faster, but writing code is usually not the bottleneck, but the handoff to another team. For example, if we have functional silo teams, or if we have the separate testing or separate deployment and so on. So when we are dealing with functional silo teams, and as a consequence, as I said earlier, then AI accelerated code generation does not increase this throughput, but piles up more work. So it increases not throughput, but the inventory. So then creates a bigger queue than at the handoff, but don't increase then the system overall performance. And also AI produces usually more code, more pull requests, more changes per day, and with more output and still the same team capacity, the team cognitive load goes up, not down. And even worse, if the teams are heavily overloaded already, then also the frustration level can increase. And before AI, the unowned areas, I don't know if you also recall, or if that resonates with you. For example, when we have areas of shared components that no one feels responsible for, usually those unowned areas grew slowly because sometimes developers or the teams were reluctant to touch those. But AI does not have this kind of reluctance. It generates into unowned area just as confidently as anywhere else. So the amount of code that nobody owns increases then at a fastest pace. And what happens then when it breaks? So who do we call then? And then also AI does not distinguish between like core differentiators and commodities. So they don't have a built-in this understanding of our business context in which we are operating. So it might invest in development efforts in areas where it shouldn't. It might, without strategic guidance, it then might custom build solutions for non-differentiating problems that already have commodity or off-the-shelf alternatives. And so when AI generates code everywhere, then teams end up with spending then review and maintenance effort on custom code for non-differentiating components as well. So these are the risks if we have not a foundation. So AI needs a solid foundation for continuous change that enables then on the one side the flow of change, but also has close alignment with domain and our a close domain strategy alignment that is able to handle then our increased speed. So we also need to consider that our organizations are typically composed of social and technical aspects that cannot be treated separately. So instead, we need to align them in order to be able to adapt to new and changing circumstances. So that requires to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of change and constant feedback. And one approach out of many is that helps us with that is to combine patterns, principles, and practices from different perspectives. For example, from the business strategy perspective, from the software design, software architecture perspective, and the team organization perspective. For example, connecting the dots between Wardley Mapping, domain-driven design, and Team Topologies as architecture for flow as a holistic tool set. And in architecture for flow also I consider this as a complementary approach with Sooner, Safer, Happier, where Sooner, Safer, Happier describes the desired outcome we want to optimize for with and principles and patterns to achieve them. And also architecture for flow then complements this with by providing the how and how to achieve those outcomes through a concrete methodology. And optimizing to build the foundation for this continuous change, we first need to understand where does this change come from? So what drives change? And change is usually driven by user needs, and user needs of our external and internal customers are good candidates for customer-driven streams of changes, so that we then need to structure our teams and our systems around these customer-driven streams of changes, then ensuring a fast flow of change where then it matters most. And that requires to start from the user perspective. And Clayton Christensen, the inventor of the Jobs to be Done series, stated that people buy products and services in order to get a job done. And in order to help users to get a job done, we first need to know who are our users and what are the jobs they want to accomplish, and need to identify then the desired outcomes as the user needs that the users want to achieve when getting a job done. To give you an example, a simple example of an online school solution for junior students, one of the user types are the teachers, and the teacher's core functional job is to facilitate remote learning. In order to accomplish this job, teachers need to prepare learning material, they need to assess student understanding with assignments, they need to track the student progress over time, facilitate communication with the students, and ensure secure access to the learning platform, for example, with sign-in processes. And the jobs to be done and the user needs, they describe the problem space, and they stay usually the same regardless of how those user needs are then solved in the solution space. And when we switch to the solution space, those user needs are directly or indirectly fulfilled by a chain of components that generate value to the user needs by satisfying those user needs. And that's where we can blend in the value chain. That is the y-axis of a Wardley map, where the users and the user needs represent the anchor of the map. And this value chain then visualizes how different components connect to generate value aligned to the user needs, and visualizes then also the components' dependencies. So coming back to the example, the teachers are interacting with an online school component directly that is most visible, that's located at the top of the value chain, and this online school component is then depending on other components, in this example on foundational infrastructure components. They are less visible and located further down. And we can start with just a few components and iterate later on. And the components of the value chain are then typically mapped to evolution stages, from left to from Genesis with brand new things, then custom built, then product and rental, such as off-the-shelf products or open source software solutions, and commodity and utility at the right. And creating a map, a Wardley map within a group, usually creates a common understanding of the business landscape in which an organization is operating and competing, and helps also to challenge our own assumption, and helps us also to assess efficiency gap in terms of addressing questions. Are we custom building components that are not core to our business? For example, are we custom building commodities? Or can we utilize further evolved components? And the map in general helps to identify areas where to invest and where to innovate, and what to evolve and outsource in order to gain competitive advantage. And I use a Wardley map as a visual tool that can guide us through the optimization. So to optimize our flow of change, we can use then this Wardley map as a high-level entry point to assess the flow of change, and can trace then the dependencies in our value chain to analyze how a change will propagate through our system by analyzing what components would be involved in a change, and what corresponding teams need to communicate and coordinate in order to make that change effective. And this can also be complemented with value stream mapping. So the high-level dependencies view of our value chain can be then complemented by now drilling down into value streams, the end-to-end process of producing and delivering value to a user, which involve then a sequence of activities for example, from planning through development to release the change to our customers. And typically, multiple value streams interact with one another. So one value stream can support another, for example, through self-service capabilities, and together they form a network of value streams. And from the perspective of sooner, safer, happier, teachers can then be represented as value consumers. That's the people, the users for whom we create value. And the user needs then form the consumer journey, the path along which our value consumers then experience the value. And then the individual value streams are then within our value chain are then the producer journeys, the value streams along which our teams then create and deliver that value. This means that when we optimize for flow, we need to optimize in that way that that value moves as quickly and as smoothly as possible along these interconnected producer journeys, and reaches then the value consumer with minimal interruptions along the networked value streams. And so, as I mentioned earlier, the teams, the value producers, should fully own the entire end-to-end flow of change, their producer journey from idea to delivering value to the customers, the value consumers, with minimal interruptions and bottlenecks. And teams often know what slows down their work. So in meeting the teams where they are and interviewing them about what currently blocks the flow of change helps to identify potential impediments, potential blockers to flow that should be minimized. But not only the blockers, but also elements or factors that support the current flow can be collected in order to understand what should be preserved then in our future to be state, in our ideal future. And those collaboratively collected pain points can then be revisited later to determine which have been mitigated, or maybe some blockers require some additional attention, and whether new challenges have emerged. But keeping in mind that at some point we need to address those bottleneck pain points or blockers that slows down our overall performance from theory of constraints. So to improve our flow of change sustainably, we need to design systems in a way that allows them to deal with change continuously, and instead of being slowed down by changes. That means that we need to establish adaptive systems, and adaptive systems are designed to be amenable to change, that can then evolve and easily respond to new and changing circumstances. And to be amenable to change and to be adaptive, that requires to architect for change and leverage the power of small. And that means that we have to move away from a monolithic big ball of mud with messy models and fuzzy boundaries, and leverage modularity with high functional cohesion and loose coupling by designing modular, well-encapsulated, loosely coupled systems, which requires to decompose our monolithic, tightly coupled big ball of mud into modular components. And that brings us then to bounded contexts of domain-driven design. So a bounded context groups related business behavior together, and the bounded context defined where a single domain model can be applied that encapsulate particular business logic. And bounded contexts are enforcing high cohesion and modularity from a business behavior point of view, and also indicating good domain logic specific seems to split the system into smaller, modular, well-encapsulated parts, but also serve very well as team ownership boundaries. We come to that one when we address the team perspective. So, and to designing those bounded contexts and also the domain models that typically involves a close collaboration between domain experts and development teams, gaining a shared understanding of the domain. And there are different techniques available to design domain models in the bounded context. And one of them, which I apply regularly, is event storming, a lightweight collaborative modeling technique invented by Alberto Brandolini, and which allows to explore complex business domains by mapping out domain events, things that have happened in our domain along a chronological timeline. And we can start event storming sessions and addressing questions coming from the user needs of a Wardley map, and address questions such as what has happened in our domain when a teacher prepares learning material, or when a teacher would like to assess a student understanding with assignments and so on, and can and express those insights with domain events, for example, course outlined or content published, or exercise assigned or student enrolled to class. And those domain events are technology agnostic, so they represent the shared understanding between domain experts and development teams. And event storming helps to share domain knowledge on the one side between domain experts and development teams, but also helps to identify candidates for bounded context. So that one that relates the boundaries that groups related business behavior together. In this example, we have bounded context of content creation or assessments, progress tracking, and so on. And those identified bounded contexts, that's where we now switch to our future landscape. These modular bounded contexts then can be part of the solution space and can represent components of the value chain for our envisioning now our future landscape. And they can address different user needs of the teachers, from preparing learning material to facilitate communication and so on. And so these bounded contexts are aligned then to the customer-oriented streams of changes driven then by those user needs. And coming back then not to now the strategic alignment, not all of those bounded contexts are equally valuable from a business strategic point of view. This brings us to the question where in the solution space we should prioritize our strategic investments. That is, which of them should that providing competitive advantage, which of them should be built in-house. And this, for example, our largest development investment should be focused on our bounded context in the solution space that are addressing our core domain. the areas that create competitive advantage. These should be developed in-house. And for unspecialized, non-differentiating areas, we should assess whether we could use existing solutions. So, for example, bounded contexts that belong to generic subdomains like identity and access, they do not provide competitive advantage. They consist of very common standardized processes and functionalities that requires little to no variation or specialization. Here we can use existing market solutions, for example, off-the-shelf products, open source solutions, or cloud-hosted services. But for the supporting subdomain-related bounded contexts, they are non-differentiating, but they are specialized to our domains, and they support the core domains offering. So the decision whether to build or buy is a little bit more nuanced. They might be so specialized that they that there is no product available in the market. Then we need to custom build it, or can use customized off-the-shelf products. Even though right now I know all this discussion right now with Gen AI, we can custom build everything. But I would also highlight and focus first on our core differentiating bounded context first. And because AI generated code generation is just one part of a product life cycle, all this operational excellence that we need, monitoring, maintenance, bug fixing needs to be considered as well. So it's still, for me, relevant whether we want to build or buy, need to build or buy bounded context solutions. And whether we could leverage further evolved components is not only restricted to our bounded context, but for components of the entire value chain. So in our example, we could decide right now to evolve our on-premise infrastructure components that are right now residing in product and rental, and migrate them to cloud-hosted services available as commodities in order to, for example, to close potential efficiency gaps. As mentioned earlier, the organization are not only composed of technical components and aspects, but also of social one. We are dealing with socio-technical systems. So that also brings us to the team perspective. And from a team perspective, we need to find suitable team boundaries that are aligned to customer-driven, customer-facing streams of changes. And as stated previously, bounded contexts, they provide well-defined ownership boundaries that makes then bounded context good candidates. Besides good seems to split our system into modular components, bounded contexts also are good candidates for team ownership boundaries, for stream-aligned teams, a team type from Team Topologies representing cross-functional autonomous teams that are aligned to a continuous stream of work, or in the context of sooner, safer, happier value producers as multidisciplinary teams as well. And also to maintain a fast flow of change, streamlined teams, they depend on other teams to support them in delivering their work and also reducing their cognitive load and increase autonomy. And so they need support from other teams, for example, from platform teams as additional value producers that provide self-service capabilities. And this requires them to identify potential platform candidates. And to do that, we need to shift now the perspective from the external customer view, where we had the teachers as the users of the anchor of our map, now to the internal customer views, where the streamlined teams now become internal customers. And now therefore we shift now from original value producers to value consumers. So they need then capabilities that supports their needs when building, developing, testing, deploying, operating their parts of the system along their consumer journey. And this means that we need to identify platform candidates that enable a reliable flow of change. For example, that we can provide different types of platforms from design system, which abstracts away, for example, style guides, component libraries, design principles, and much more. But also maybe also infrastructure platforms that helps us to provision our infrastructure with providing then self-service capabilities, or like a build platform with CI/CD pipelines involved, or operating and monitoring platforms. And also in Sooner, Safer, Happier, these are then referred as shared service value centers. And simply organizing teams into different team types is not enough to ensure effectiveness, but how teams are interacting and when to change and evolve the team interaction is also crucial for optimizing our flow of change. For example, a platform team may initially collaborate with one of the Streamline teams for a limited period of time to understand the Streamline team's pain points and needs to deliver value. And we might want to revisit the previously identified blockers to flow in order to address those blockers that helps them to mitigate them in order to, for example, reduce cognitive load or reduce handoffs between teams. And over the time, this collaboration could evolve into X as a service, where the platform teams provide self-service capabilities that allows then the Streamline teams to consume platform service autonomously without actively interacting to the platform team. So reducing then the handoffs to other teams. And additionally, also Streamline teams can, of course, temporarily collaborate. For example, when exchanging insights, gained experiences, or when exploring practices together to, for example, how to modelize our legacy system in small increments by extracting our bounded context from a big ball of mud system. And if teams lack certain skills, enabling teams can also engage as internal coaches then supporting other teams acquiring missing skills on demand, and also facilitating on demand, being pulled in on demand as a temporary interaction mode between teams as well. And when you ask yourself, how can we use those contexts yourself now to bring all these practices together, I developed an architecture for Flow Canvas that provides a very lightweight structure that helps us to design adaptive socio-technical systems, optimizing for a fast flow of change. But it's not a rigid framework. It imposes as little structure as possible and can be complemented, of course, with other tools and frameworks as well. So, and it can be adjusted to your own context as well, of course. And it starts usually with the teams of today and works step by step towards this the teams of tomorrow. And it helps us to establish in a direction that we want to move forward, but can be course corrected along our journey. So it's not set in stone. So it usually starts with assessing the current state, our status quo, and analyzing the current teams and the team dependencies, including also their responsibilities, assessing the current flow of change to identify current blockers to flow, and mapping the current business landscape in which the organization is operating and competing in. And then from assessing and understanding our current state, we can then gradually move to designing, envisioning our ideal future, but as I said, as a first working assumption. So by categorizing and distilling our problem space into core, supporting, and generic subdomains, that helps us to identify areas that provide competitive advantage, and modelizing then the solution space into modular components with bounded context, for example, running event storming sessions and bringing those insights back to a Wardley map, envisioning then the future landscape, business landscape, to now better target our strategic investments, and then eventually aligning then the teams, future teams, and the future team interactions between the teams to the system we build and the strategy we plan. So, and as I said, the ideal future is not set in stone. It's not a big upfront design, but considered as a first working assumption that is in progress, work in progress, and providing then initial direction for movement that can be then course corrected as soon as we gain more insights during our journey. So at this stage, the initially identified blocks to flow can be revisited to assess which of them we were able to minimize, which still needs some addressing, and whether new obstacle have emerged. This architecture for flow approach helps us to unlock a variety of blockers from the architecture, from team ownership, team dependency, and efficiency gap, and working management perspective. But if you remember where we started with the questions, with a question, what happens when you add AI to a system full of frictions? And we saw the risks where, that AI mirrors then the structures it finds, or it mirrors our broken structures. It amplifies our organizational frictions, and helps to build the wrong thing faster. And what happens when we now have mitigated those blockers and address those green sticky nodes now? What happens when we have established those modular, well-encapsulated, loosely coupled system with bounded context? For example, that groups related business behavior together, enforcing high cohesion, and so that means that business logic is not longer scattered across the entire system. And so now when AI infers meaning from patterns in its surrounding context, then it can now pick up patterns that are now semantically coherent. And so that means that we can potentially then the hallucination of domain meaning can be significantly reduced, and AI generated code is now better aligned to the domain. And a bounded context also forms a linguistic and semantic boundaries. So the terms and meanings of our domain models are now consistent and clear within its boundaries. So when AI picks up now naming and patterns from the code base, it now finds and amplifies consistency rather than propagating inconsistencies as we have seen before. So now it can detect and even refactor inconsistent naming within a bounded context better than before. So it helps us to amplify then consistent naming and models within our bounded context. And with well-defined domain models, encapsulating then business behavior and loose coupling between the bounded context, now AI mirrors now the good structure it finds, and it reinforces modularity instead of like creating more coupling as we have seen before. So an AI can now operate independently within a bounded context. So, and also from a business strategy point of view, then with clear strategic guidance to focus our major development efforts, investments then on our differentiators, then is now AI-assisted development is now directed towards more core domain differentiators rather than custom building everything, even commodities. So AI now invests efforts where it matters more in terms of our differentiators. And closing efficiency gap with standardized commodities that helps us, that provides now strategic guidance that minimizes the risk of AI accidentally custom building commodities, and development effort, no matter of human or AI assisted, is now directed towards developing components that creates competitive advantage. So it's more on value, focuses more on value creation, not reinventing. And also well-defined ownership boundaries. Bounded contexts, as I said, serve as well-defined team ownership boundaries so that we reduce the areas of unowned, areas that AI, so that means that every line of AI generated code falls into teams' responsibility, ensuring accountability. So we have now a clear ownership involved. And also with teams now owning right-sized parts of the system aligned to their cognitive load, the increased output from AI-assisted development now remains in the team's ability to review, understand, and maintain. So now it's increases the AI-generated code remains now manageable. And also cross-functional autonomous streamline teams like owning the entire end-to-end flow. There are no handoffs between teams anymore in an ideal case, so that AI-generated code can pile up in. So it is now AI-generated, accelerated code generation now actually translate into increased throughput, not just like, and can now flow end-to-end instead of like increasing inventory at the handoff. And also platform teams providing self-service capabilities ensures that that the infrastructure can absorb like the increased pace from AI system developing and keeping then this flow smooth and reliable. And so that is the AI speed is then sustained by those platform capabilities. So the combination of Wardley Mapping, domain-driven design, and Team Topologies helps us to unlock a variety of blockers to flow and helps us to generate value aligned to user needs, helps us to architect for change and leverage modularity, focus major development investments on our differentiators, providing competitive advantage, helps us to close potential efficiency gaps and align our teams and evolve their interactions to the system we build and the strategy we plan. So that's what I call architecture for flow, the foundation for designing and evolving adaptive socio-technical systems that are optimized for sustainable value, for a fast flow of sustainable value and constant feedback delivery. And also the importance of this, applying these foundations is not new because of AI, but now it becomes even more crucial for AI. So providing then guardrails for a safe AI adoption. Oops. And so, as I said before, like sooner, safer, happier describes the desired outcomes we want to optimize for, and architecture for flow then complements this with a concrete structural foundation. How do we align our business strategy, our software design, our software architecture, and our team organization so that these outcomes can be actually achieved? And with that, I thank you so much for listening and looking forward to your questions.